Okay, this is the calculus lesson 4.1. We are starting integrals, and the terminology is actually going to be, first of all, antiderivatives. So we're going to talk about antiderivatives, which are also called indefinite integration. So we're going to learn how to find antiderivatives, and we're also going to call that indefinite integration. When we have a derivative, it's called a differential equation. So if I were to tell you f prime of x equals 2, I'm telling you the derivative of f is 2. So this is called a differential equation. When we're trying to find the solution to a differential equation, we're going to start off finding general solutions. And here's what I mean by this. We're basically going backwards. I say to myself, if f prime of x is 2, if the slope is 2, where could this have come from? Well, it could very easily have been y equals 2x, because the derivative of 2x would be 2. Now, the reason it becomes a general solution is because this could have been 2x plus some number, because anytime you take the derivative of a number, it's 0. The derivative of 2x would be 2, the derivative of a number would be 0, so this could be y equals 2x plus some number, which would have to be a constant. So we would say our general solution is y equals 2x plus c. The plus c part is what makes this a general solution. And starting for this lesson, for sure, we have all general solutions. So let's talk about how do you find these antiderivatives? How do you work through this process? Well, if I told you that f prime of x is 3x, I'm telling you that this is the differential equation. The derivative of f is 3x. So where could this have come from? If I had 3x, where could it have come from? Well, we know that x had to have come from being x squared. And so if we ended up with a 3 as our number in front, we'll think to ourselves, okay, if I took the derivative of x squared, that would bring the 2 to the front. So 2 times what would give me 3? And that what would have to be 3/2. Because if I came over here to the side, just to show you, 3/2 x squared, you'd bring the 2 to the front. 2 times 3/2 would be 3, x to the first power. That would be your derivative. So now we're going back the other way, and so we're saying 3x becomes 3/2 x squared, and then I have to also put a plus c, because I don't know that there's not a constant out there, and we don't know exactly what the constant's going to be, but we're going to learn that actually a little bit later on in this lesson. So how did I figure this out? What is the pattern that I'm looking for? I had 3x, how did I get 3/2 x squared? Well, I went from x to the first to being x to the second, so I definitely added 1 to my exponent. So let's say I had x to the n, and I wanted to find its antiderivative. I would definitely do n plus 1 for my new exponent. But how did we get this constant part here? Well, we had a 3 already, so we're going to call that c. But how did we get the divided by 2? What does 2 match up with? Well, the 2 matches up with my new exponent. So I kept the constant I had before, the 3. I changed my exponent one level up, and I divided by that new number there. So I'm going to call this cx to the n plus 1 divided by n plus 1. So what's the process? To find an integral, to integrate something that is already a derivative, you're going to add 1 to the exponent, and you're going to divide by that same number. Whatever this number is what this number is going to be. So let me show you some examples of how this works. Most of the time you have to rewrite to integrate. And so if I have 1 over x cubed, I would start off by writing that as x to the negative 3. This funny looking s is the integral symbol. So this is saying integrate 1 over x to the third, and the dx part is just telling me that it's a derivative. So I rewrite it as x to the negative 3. I'm going to go ahead and keep that dx. And x to the negative 3 is going to become x to the negative 2 divided by negative 2 plus c. So this was negative 3. If you added 1 here, your new exponent would be negative 2. And so this number and the divided by number are always the same. So x to the negative 2 over negative 2 plus c is my answer. So for the next one, I'm going to integrate this. First, I'm going to rewrite the square root of x as x to the 1/2 power. Then I'm going to follow my rule. Add 1 to my exponent. So 1/2 plus 1 is 3/2. And now I'm going to divide by 3/2. And I actually can go ahead and rewrite that, because when you divide by a fraction, I can flip it over and make it 2/3 x to the 3/2 power. I didn't leave myself much room here. 2/3 x to the 3/2 power plus c. All of your general solutions have got to have a plus c. And so I know before I even start that I didn't leave enough room on this last one, so let's give it a shot. It's a little bit different when you look at trig, because you have to think, where did this come from? Well, the 2, actually, I don't need the integral sign over here. The 2 is still going to just be 2. Remember, it's a coefficient. In reality, anytime you have a coefficient, you can actually move it outside of the integration. So the 2 stays. Now, where did sine come from? What would sine have been the derivative of? Sine's derivative is cosine, but where does sine come from? So sine's the derivative of negative cosine, and then of course you have your plus c. So when you do integration, your symbols are going to be opposite. The derivative of sine is positive cosine. The integral of sine is negative cosine, because you're going the opposite direction. All right, here's some more examples. What if I just want to integrate dx? What is dx? Where does dx come from? Well, dx means the derivative of x. So if we have the derivative of x and we're integrating it, then it's going to go back to become x. And then you put your plus c. What about if we want to integrate x plus 2? Well, we're just going to integrate them individually. If I integrate x, it's going to become x squared over 2, because this exponent was 1, so you add 1 and get 2 and divide by the same number. And then where does 2 come from? Well, 2 currently does not have an x, so when you integrate it, it gets an x. And then we do plus c, because it's general. And then we have a longer polynomial for the third example here. And we're still just going to go step by step. 3x to the 4th would become 3x to the 5th divided by 5. 5x squared will become 5x to the 3rd divided by 3. X becomes x squared divided by 2. And then I ran out of room, but don't forget your plus c. Okay, as I've said before, when you integrate, almost every time you're going to rewrite it so that you can integrate it. There is no product rule, there is no quotient rule, there is no chain rule. Some people love that, but if there's not a rule, there's not always an easy way to break it down. So we're going to start by rewriting it. I'm going to write this as x plus 1 divided by x to the 1/2 power. And actually I can go an extra step and write that as x plus 1 times x to the negative 1/2 power. I'm just bringing the x to the negative 1 up here and writing it as x to the negative 2. Then what I'd have to do is distribute this. So x to the negative 1/2 times x to the 1st is going to become x to the 1/2 plus x to the negative 1/2 times 1, which is x to the negative 1/2. Notice that all I've done so far is rewrite. I haven't done any integration. So now let's integrate it. X to the 1/2 power becomes x to the 3/2 power divided by 3/2. X to the negative 1/2 power, when you add 1, becomes to the 1/2 power divided by 1/2. And you're also going to have plus c. And then take that x to the 3/2 plus 2x to the 1/2, because 2 is the reciprocal of 1/2, and then of course plus c. And so that's my actual final cleaned up solution. All right, and then I had example 6, which, two things, has trigonometry in it, and also you have to really rewrite this. So first of all, to rewrite it, I'm going to write sine over cosine squared x as sine x over cosine x times cosine x dx. When I do that, you might be able to see right off the bat that I can do some grouping. Sine x over cosine x is tangent x. And that leaves me with a 1 over cosine x, which is secant x dx. Okay, so that makes a totally different problem. Now when I want to integrate this, I just have to think to myself, where does tangent secant come from? Well, actually, we usually see it in the reversed form, but secant tangent is the derivative of secant. So if we integrate secant tangent, it integrates back into secant x plus c. Okay, probably the most important example that was left off of the last video is example 7, where we're going to talk about particular solutions, because this is something that's going to come up especially in free response questions. Okay, so FRQ alert right here. If you're given a problem like this where they give you a derivative, you can know it's a derivative because it has a prime. So f prime of x is 1 over x squared, and they give us an initial condition. That's very important. Then we're going to find the particular solution. To do this, we're just going to start off by integrating our differential equation. 1 over x squared is our differential equation, just rewriting it. So the integral of 1 over x squared is the same thing as the integral of x to the negative 2. And to integrate that, I get x to the negative 1 over negative 1 plus c. Now what I should say about this is that this is really equal to f of x equal to f of x. Okay, so my f of x is now negative 1 over x plus c. Went ahead and simplified this just a little bit. Okay, so how that helps me is that I was given an initial condition, f of 1 equals 0. That means this is the x value and this is the y value. And so where f of x is, I'm going to put 0. And where x is, I'm going to put 1. And that's actually going to tell me what my c equals. So if 0 equals negative 1 plus c, then c is going to be equal to positive 1. So that gives me a particular solution, because when I go back to write this equation, I'm going to say, I'm not sure where I'm going to put this, but I'm going to go back and say, let's go right here. There's a little bit of space here. Okay, so now I know f of x is negative 1 over x plus c, but we know our c is 1. So now I have a particular solution. The general solution had the c. The particular solution has been solved to find out what that c is equal to. Okay, and then here are the here's the assignment that went with this, and if you haven't already done it, you can do it now.